Hi, welcome to my channel, The Machining Maestro. So today I'm going to explain you the programming of step turning for a CNC lathe by using Siemens Sinumerik controller. So what is step turning? Step turning is the maintaining of different diameters up to different length in a single cylinder by using the lathe operation. So from this isometric model, you can get the idea that this red color transparent portion is the material we are going to remove to produce a step kind of cylindrical structure in your raw material. So coming to the orthogonal view, here you notice this red hashing portion is the material we are going to remove to produce a step kind of structure for you. So the raw material size is diameter 40, is having length up to 50 mm. However, we are producing a step of dia 10 up to 15 mm length and producing dia 30 up to 30 mm length. So before going to create the program, we should know how to calculate the uh, points in the path, so that the machine will follow those points as a path to produce the component for you. So before going for the machining process, or before going for the programming, we should know the how to get the value of the points in x and z coordinate system. So I'm calculating the positions for you. So here the point number 1, for the point number 1, the x value is here 10, because at point number 1 the diameter is 10, and the z value is 0. The z value is 0 all the time over here, so put 0. Now coming to the point number 2, you notice the same diameter has been maintained till 2, so the diameter will remain 10 only. But the z value has been changed to 15 mm, so write down minus 15. Why I'm writing minus? Because we are going in left direction or negative direction, that's why I'm writing minus 15. Now coming to the point number 3, at the point number 3 the x value is getting changed, the diameter has got changed, so it has changed to 30, so write down 30. But the z value has remained same as it is, so write down minus 15. Now go to the point number 4. At the point number 4, the x value has been remained same, so keep as it is like the previous point 30, but the z value has got changed to 30, so write down minus 30. Always calculate the distances from the origin position. This is the origin, so whenever you calculate the diameters, you calculate from the center point as a center axis, and whenever you calculating and wherever you are calculating the z positions, you calculate from the face of the workpiece. Okay, now go to the point number 5. At point number 5, the z value has remained same, but the x value has got changed, so the x value will be 40 and the z value will be minus 30. Okay, so this is all about how to get the points, because these points are required to create the contour or to create the path which the machine will follow to produce the part for you. And coming to the tool data, here I have used PCLNR 2525 M12, uh, where the CNMG 120408 is fixed. So this tool we are going to use, and in my next slide I'm going to tell you regarding the tool data. It is all about your tool data. This is the tool, and the black portion is the holder and the yellow portion is the insert. The holder name is PCLNR 2525 M12 and the insert name is CNMG 120408, and this is called the ISO designation of the holder, and this is the ISO designation of the insert. This designation has some meaning, so the meaning I have briefed you in the left side. And here is the meaning of this designation available here. The meaning of P is the clamping type, which is P type clamping, and there are already various kind of clamping. P is one of them, and the C is the insert shape or insert angle, which is 80 degree. The angle which is producing over here is 80 degree. The tool holder type or tool holder angle, the angle is produced between this surface and this surface is 95 degree. The insert side clearance angle is 0, which represents n. N represents the side clearance angle is 0 degree. The angle is produced over here is 0 degree. And R is representing the right hand cutting tool, and 25 is the shank height, and 25 is the shank width, and M is the total tool length, and toll is the insert cutting edge length. The length of this yellow portion's wall, which is the cutting edge, the length of the cutting edge is 12, which is in mm. So this is all about the ISO designation of the holder. Actually there are many kind of holders and of their many kind of designations, many kind of designation meanings, which I will explain you in my coming videos, where I will take the example of many different kind of tools and their ISO designations, and we will discuss one by one over there. So just it is just a quick briefing for you to understand this tool, because this tool we are going to create in our machine controller, so that this tool can be used in the program and you can check the simulation properly. And now come to the insert data. The designation says C is the insert shape or insert angle, which is 80 degree. N is the insert side clearance angle, which is 0 degree. The clearance angle is produced over here, which is 0 degree. M is the grade of tolerance or class of tolerance. There are many grade and class of tolerance. M is one of them. And G is the fixing type or chip breaking type. The inserts are always designed with some chip breaking formula or chip breaking designs or fixing designs. There are many kind of such designs. So G is one of them. And tool is the cutting edge length. Tool is the cutting edge length in mm. The cutting edge length is the length between the two adjacent sides of the insert, which is tool. 4 mm is the thickness of the insert, and 0 it is the corner radius or nose radius, which is in mm, but 0.8 mm, not 8 mm, it's 0.8 mm. So you see the CL12, C1208, these are I have highlighted in red color letter. So these are the information which we require to create the tool in our machine controller. So let's go and create the tool over there. Thank you. This is your machine interface. We are going to create our new tool. For creating new tool, you go to offset, and in this window you see there are already many tools in your tool list, and they are situated in different magazine locations. You can see from here. So if you want to create a new tool, actually there is two type of method. Maybe you can delete this tool, or maybe you can unload that tool, and at that position you create your new tool, or else you can create your tool at any empty position. But if your turret is having 8 number of tool stations, then you can use the location up to 8 only. If your turret is having capacity can carry up to 12 number tools, so you can use your location up to 12. So meaning in my case, I'm going to create my tool at location number 1, for example. So that's why I will delete this tool, or else I will unload this tool. So for unloading this tool, you click unload. So while unloading, the tool is getting placed at the bottom of the tool list. So later you can load it to any position or any location position you want. But for deleting any tool, you just click here and press delete. So after pressing delete and clicking OK, the tool is getting disappeared completely. The tool is not available for you anymore. So so these are the two cases. So if you want to load this one, you click here and press load. It is asking in which location you want, so you can give 9 to anything. So I'm giving 9 number, then or maybe 10 number. So you see that in 10 number there is no tool available. You press OK. The tool is now at location number 10. So in this way you can load unload your tool. Loading is a good option because later you can use that tool, and the parameters will remain same. All you need to change your offsets only. Offset meaning the references only. So at the position number 1, location 1, I'm going to create my tool. For creating the tool, you click on new tool, then choose your tool. Our tool is the roughing tool because PCLNR is a roughing tool. And out of these cutting edge positions, you select the first one, then press OK. Then give your tool name. I'm giving PCLNR 2525 M tool. Then press input. So after pressing input, the sister tool and the cutting edge position, these two are become one and one, because there is no such tool kind of tool is available in your tool list. If you find any PCLNR 2525 M tool, same identical tool over here, the sister tool become two. But since only one tool is over here, that's why the sister tool is only one. And D is the cutting edge position, cutting edge number or cutting edge position, that we will discuss something later. All about this tool list creation and detail tooling part, we will discuss something in my later coming videos. So there I will explain you everything in detail, but here I am giving you just for giving you such some idea, just for a example, because without creating your tool you cannot check your simulation in your machine, or else without creating the tool you cannot run your program. So the parameters are really important. So I'm showing you how to store the parameters here. So the sister tool gone, the cutting is gone. Length x, length z. Length x is the distance between of your tool to the diameter of the workpiece. So when you take the references, when you take the offsets, that time the values are automatically getting stored over here. And in case of z also, it is the distance between the workpiece face to the tool. So so these two are something you will get, or it will be automatically restored when you take the offset. So since we are not doing any practical over here, I'm just putting some random values like -200 and -300. Okay. So in the radius part, that is something we got to know from my previous slide, where the nose radius I have told you it's 0.8. So you write down 0.8, then press input. Then this is the cutting direction. So out of these four, you choose this one. Okay, if you want to look for the option, then you go here and press select. So out of these these four options, you select this one, then press input. And this is the column where it is asking for the holder angle. The holder angle I have already told you, that is 95. Then write down 95, then press input. Then the next column, it is asking for the insert angle. Insert angle is also 80 degree here, so you write down 80 and press input. Then it is asking for the plunger length. Plunger length is nothing but the cutting edge length. So cutting edge length you keep 12, because in our tool the cutting edge length is 12. So press input. Then it is asking for the spindle rotation, but this is not a this is not a milling machine, or this is not a ton mill. So that's why the spindle option meaning doesn't matter. So keep it as it is. and go for the next option. Then it is asking for the coolant, and 2 is the dedicated coolant. So coolant is also, even though you click it on, you have to write the um, coolant on program in your full program. So if you want to turn it on and turn it off, that is up to you. And similarly, the coolant number 2 is something that if you turning it on, then if you have some dedicated to coolant supply option, then that will be turned on. So from here to here, like from this length z, radius, the cutting direction, holder angle, insert angle, and the insert cutting edge. These are something the really important parameters. And length x, length z is something are getting stored automatically when you take the offsets or the references. So radius and cutting edge direction, holder angle, insert angle, and the cutting edge length, that you need to get the data from your tool and put it here, so that your simulation will be very proper for you, and you can visualize your mistakes or visualize your proper machining process in the simulation. So next we are going to show you how to create the program. We are going to create the program. For creating the program, press program manager, then press this plus icon on part programs. Already there are two programs which I have shown to you in my different chapter videos. So now we are going to create a new program here. Press new, then define the program name. I'm defining the program name in capital letters, step turning. Now press OK. And first we are going to create the workpiece. Press various, then press blank, choose the blank type as cylinder. XA is nothing but your diameter of workpiece, which is 40. Then press input. ZA is the starting length of your workpiece, which is always 0. Write 0 here. Then press input. Zi is your in negative direction, and it's the total length of your raw material, which is minus 50 as per your drawing. Then press input. Then ZB is the amount of length of the raw material you are keeping for the machining. Since we are going to do up to 30 machining over here, so we should keep the Z value more than 30 So I'm going to keep minus 35. Then press input. Now press accept. After that, write down the pre-operation commands. Press input. I'm writing the pre-operation G codes and or any commands. So the first command is Z90 activation of absolute mode, then Z71 activation of metric mode, then Z95 feed in per revolution, then Z64 continuous path control mode activation. Then you write down the homing program T0D0 Z0X0, then input, T0D0, then press input, then write down Z0X0, then click input, then G0Z0, then input. So this three line gives you the homing result. Then you call your tool by click on edit, then select tool, then select this tool, then press OK. Now press input. Now you write down the spindle on command M3, the spindle rotation in clockwise, and S700, the RPM of spindle will be 700. Then press input. Then you write down the safety positioning of tool before approaching for the machining. So the safety position will be Z0, Z2.0, safety height in Z axis. Then you write down Z0, X42.0, because our workpiece is having diameter 40, that's why I'm writing 42.0. And the starting position of the Z axis is 0, that's why I'm writing Z2.0. then click input, then you write down M7 which turns on our coolant. Then you press again input, then press on contour turning, then click on contour, then click on contour call, then define a name. I'm defining the name STEP, then press accept. This name should be followed throughout our program whenever it is required. So now press input, then again click contour turning, then click on bake, then click on stock removal, then in the input option you keep it simple, then in programming you write down the program name step, then in feed rate in feed rate you define the feed rate as 0.2, then input, then the machining type you select either roughing or finishing or roughing plus finishing. I'm selecting roughing. Then here in the machining direction you select longitudinal. Out of these three options, face is for facing and contour parallel is the combination of both longitudinal and facing, but I'm selecting longitudinal here. Then you select the positioning of your workpiece, whether you want to do the inside operation or outside operation. Since you are doing the external operation, that's why I'm selecting outside. Then this is the direction of cutting. Since our tool is situated in right side and chalk is situated in left side, so our direction will be always like this. If your chalk chalk is at chalk and turrets are in opposite direction, then you select this one. So I'm selecting this one. Then it is asking for the incremental depth of cut. Incremental depth of cut meaning it will follow the follow this much depth in a single pass. So with the combination of number of passes it will complete the cycle. So 0.2 0.2 or anything you are giving, no, that value it will follow till the completion of cycle. So I'm giving 0.2 here. Then UX is the allowances you are keeping at the periphery of the workpiece. So 0.1 is okay, or else if you want to change, then you write down 0.2. Then UZ is nothing but the material you are keeping at the wall of the workpiece for the finishing cycle. That is also you can change. So I am changing it to 0.05. Then press input. Then blank type, you select cylinder. Out of these three, cylinder is for like for a complete raw material you select cylinder. Allowance is something you select for for finishing operation, and contour is something you select when you have a pre-machined surface, then you select contour. So here I'm selecting cylinder. Then XD is nothing but the diameter of your raw material, which is 40. Then press input. And ZD ZD is nothing but the starting length of your workpiece, which is 0, because your datum and the starting length of your workpiece is 0 all the time. So you select 0 and keep all these two in absolute mode. Okay. Now coming to the relief cut. Relief cut is something which is required when you are doing such inverted kind of profile. So that time relief cut need to be turned on. So you keep this turned on. Meaning even though you are not doing any kind of relief cuts here, but if you are keeping this, then no problem. Then it is asking for the feed rate when you are doing the relief cut, because during the relief cut the machine tool the tool plunges over the workpiece. That's why you need to deaccelerate the feed rate. So that's why the feed rate should be reduced. It should be a reduced feed rate. So you give anything you want, but here it doesn't matter because you are not doing any inverted profile, you are just doing step turning. So this is just for example, just for practice. So later we are going to use that. Now press accept. Then after that press input and write down your post operation commands, which is Z0, Z2.0, pulling out your tool to the Z safety position, then M5, M9, spindle off, coolant off. Then you write down homing program T0, D0, Z0, X0, sorry, T0, D0, then input Z0, X0, then input Z0, Z0, then input, then you write down M30. M30 is the program end command. So after that, press input. Now it's the time to to give the path details to the machine. To give the path details to the machine, you click on contour, then click on new contour, define the same name as given here, HTEP, then press accept. Then this is asking for the first point, and from here you can see the first point is diameter 10 and the Z position is 0. Then press accept. So the second, at the second point, the we are going in left direction horizontally, so you click horizontally. When you click horizontally, the machine considers that your x value remains same, so you just need to put the z value. So z value is minus 15. Then press accept. Then we are going for diametrically change, so you click on this vertical icon, you click here and provide the x value 30. Since your z value is same, so the machine is only asking the x value. Then press accept. Then again we are going with the same x value in z direction, so click on this horizontal icon and then define the z value minus 30. Then again we are going we are going up, meaning in x axis, so you select this one with the same z value. The x is now 40, so you define 40 here, then press accept. So this is all about your path. This path you need to provide to your machine, so that this machine will follow this path to produce the part for you. So press accept now. So the path got created over here. Now we will check the simulation. Click on simulation. So click on 3D view. Now the machining will be started. See, the tool has come here. It is approaching and removing the material from the periphery of the workpiece. And if you want to increase the feed rate, increase the speed of simulation, also possible here. So side view also you can see, further views like face view also you can see, and half cut view also you can see, two windows also you can see. So I like the 3D view, and you can zoom it also, zoom from here like. So it is the amount of material we are keeping for the machining outside of the job. That is also necessary to check whether your tool is touching the chalk, or tool is crashing with the jaws, things like that. So during the workpiece creation, this is really important. So here the diameter is getting changed. You can see it is taking the depth of cut, incremental depth of cut what we have given in the program. So that same incremental depth of cut it is following. Okay, so the machining has been completed, and from the side view also you can check that 30 has been maintained over here, and the diameter 10 is also maintained over here, and lengthwise 15 mm and 30 mm is also has been maintained. And some allowances like what we have defined over there, the allowances has been left by the tool for the finishing cycle. So this is all about your step turning operation, or else you can say the contour turning operation. So This is all about the machining process for step turning. Thank you very much.